Okay, we're going to look at some notes specifically on indirect measurement. It's the last page of the similar figures packet. So we put the similar figures packet on 28. It is the last page of it. So indirect measurement is the process of using similar shapes. So let's go ahead and write the word similar. And proportions to find a measurement, just like we did with similar figures. Indirect measurement, so go ahead and write the word indirect measurement, can be used to find the measurement of objects that are too difficult to directly measure, such as the height of a building or a tree. Now we're going to look at this first example right here. You can, and I might be going fast, but you can pause the video at any time and re-listen to it, slow me down, speed me up, etc. So it's nice to have a video because you can replay it as many times as necessary and pause it whenever you want. All right, take a look at this. We have two triangles named, which is very helpful. We have triangle ABC and triangle LMN. Remember that this symbol right here means similar to. Why is that good? Because now we know that the sides correspond and the angles are congruent, which means equal. Better than equal, right? Same size, same shape. We're going to find the unknown measure of the triangle, which you can see is X right here. The first thing I'm going to do, though, is I'm going to highlight similar or corresponding sides. And I'm going to use the names of the triangles. So AB corresponds to LM. So I'm going to go ahead and highlight AB. And it corresponds to LM. Now that's also down here to fill in. So I'm going to go ahead and put LM. And I'm going to use the segment bar on top because it is a segment L to M. All right, the next one I'm going to highlight is A to C. Now if I look at my thing, A to C corresponds to L to N. So let's do A to C. A to C right here corresponds L to L to N. So this is this one right here. The hypotenuse, if that's a right triangle, but not sure if it's a right triangle because it doesn't have the box in the corner. All right, we're going to go ahead and look at BC now. So B to C would match up with M to N. So let's do that. B to C matches up with M to N. Now we can go ahead and write those in our on the lines right here too. So B to C lines up with M to N, and A to C lines up with L to N. Okay, so those are the sides that correspond, which means those are the sides we use to do our proportion if we need to make a proportion. So right here it says set up a proportion based on the corresponding side. So this is just practice for what we're doing. So it says AB, so if I look up here, AB is 9, so I'm going to go ahead and put 9. AC is 15. So they're doing, if you take a look at what they're doing a small to small. A small to small ratio, which means I'm going to do big to big here. Okay, if they did small to big, I'd have to do small to big on the other side. But they did AB to AC. So then I'm going to do LM, which is 31.5. to LN, which is X. Now, if you're wondering how they got those, you can just see from here, if you look up here, here's A to B, and then this is A to C. So they did a small ratio of this side of the triangle to this side of the triangle. And then it has to match on the other side. So the other side, you have to use the yellow and the blue because those are the sides they correspond. And since they did yellow first, they have to do yellow first here. Then they have to do blue here because they're doing small to small equals big to big to figure out what X is because they're in proportion. It doesn't necessarily matter how you set up those proportions as long as you use the same pattern each time. All right, so now that we have this, we're going to go ahead and solve that proportion, and we're going to do it right below in C. We're going to go 9x equals, and then we're going to multiply 31.5 times 15. If you put that into a calculator, you get 9x equaling 472.5. Okay, and then after that, you're just going to divide by 9x, so you can go ahead and do that now, which should be 52.5. 0.5. centimeters. Okay, so we just used a proportion to solve for the missing length of these two similar triangles. Okay, let's go ahead and take a look at the one to the right. This is a tree. We're trying to figure out the height of the tree then. We're going to use this same concept that we used right here with similar figures to do the height of the tree. So we're going to go ahead and look at what we have here. We have a person, okay, a person who's standing here, and then the sun must be shining on both of these because you can only do this when the sun is out so that you have a shadow. This person's height, I know you can't see it very well, but he's standing here. This is it, right? So this person's standing here. Let me give him some arms. There you go. And he's 6 foot tall. That's the height of the person. He's casting a shadow. This is his shadow right here. I'll do his shadow in pink. This is the person's shadow. Now, that same sun is casting a shadow on this tall tree. So the tree's height is X, but then it's casting this 24-foot shadow right here. Same sun, okay, same angle. And you have to do this quickly if you're out in the sun because it moves, right? And then the shadow gets smaller or bigger. So we're going to go ahead and think of these as two triangles. And then I'd put the height of the tree probably here at the edge of that 24 feet. And then work with it like this. Okay, so now we're going to highlight the sides that correspond so I know how to set up my proportion. So the height of the guy is going to correspond to the height of the tree. The hypotenuse, well, let's do it in a different color here. The hypotenuse, which is the side that connects the two legs of a right triangle, I'm going to highlight in yellow. So those two sides correspond, which I probably don't even need those two sides. And then I'm going to use blue to do the bottom of the triangle, which is the shadow length. Okay, so the shadows will correspond. So now we're going to set up a proportion to show the relationship between the actual heights to the length of the shadows. So we're going to first do the man. So I'm going to do my first proportion with the man. We're going to do his actual height, which is 6 feet. Let's go ahead and put a 6 up here. We're going to take his height to his shadow length. His shadow length is 8 feet. Okay, and I don't really need the units because I'm all in feet here. Now we're going to say that that is, because they are similar figures, right? Same angle. The shadow is getting hit in that same, the shadow is being displayed on the ground at the same angles if the sun is shining on both of these objects. So then we can set up the proportion equal to the measurements of the tree. So the height of the tree is unknown, so we're going to put our X there. But we do know the length of the shadow of the tree because that's something we can measure because it's on the ground, and that's 24 feet. So then all we have to do is solve the proportion. So you can think of it as height of the man to shadow of the man equals height of the tree to shadow of the tree. And you can do that with a building too. We're going to go ahead and use our cross products here. We're going to do 8 times x. We're going to go ahead and do 8 times x equals 24 times 6. 24 times 6 is going to be 144. And then I'm going to divide 144 by 8. And 144 divided by 8 is 18. So the answer is 18 feet. Now, you could have saw the scale here. They just times by 3 to get 24. So you would do the same to the top. So if you saw that right away, good job. And that is 18 feet. Okay, so we're going to do some more in just a bit, but that's the start of our indirect measurement lesson. Thank you.